Okay, so Unit D, we're talking about forces. And so now in D02, we're beginning our discussion of one-dimensional forces. So we've got D02, one-dimensional forces worksheet. Let's begin with number 1. It says an airplane is accelerating down the runway. The mass of the airplane is 17,000 kilograms. If the engines are producing a net thrust of 49,000 newtons, what is the acceleration of the airplane? So this is a very basic force problem here. So remember, force is equal to mass times acceleration. Okay. So if we rearrange that, we want to find the acceleration of the plane. Okay, so we're going to find A. And we are given that the mass of the airplane is 17,000 kilograms. So mass is equal to 17,000 kilograms. And the engines are producing a net thrust, so that's our applied force, so a net thrust of 49,000 newtons. So our force is 49,000 newtons. Okay, so 49,000 newtons is our force. Our mass was given to us as 17,000 kilograms. So all it is a matter of plugging into our equation here of A equals F divided by M. Okay, so A is equal to our force, which is 49,000 newtons, divided by our mass, which is 17,000 kilograms, and that will give us our acceleration of, excuse me, that will give us our acceleration of 2.9. Okay, using significant figures. I have two significant figures, two significant figures, two significant figures. Okay, 2.9 meters per second squared. And that's it. It's as simple as that for number 1. Make it nice and easy to start off with. Okay, so moving on to number 2, now we've got something that we're going to have multi-step here. So it says you're driving a 1,750 kilogram car. Okay, so there's our mass. Okay, so our mass is equal to 1,750 kilograms. You're driving down the highway at a speed of 25 meters per second. So our initial velocity, so we're starting out, our initial velocity is 25 meters per second. An accident has caused traffic ahead to slow down. Okay. What force do the brakes apply to the car if it takes you 4.0 seconds? So our time is equal to 4.0 seconds, okay, to slow your car to a speed of 15 meters per second. Okay, so our final velocity is equal to 15 meters per second. Our time was 4.0 seconds. We are looking for the force. Okay, what force do we need to apply? So what force do the brakes need to apply? So our force is equal to what? And I don't like that highlighter tip, so we're not going to use that anymore. Okay, so in order to figure this out, first we need to figure out what our acceleration is. Okay, so remember, acceleration is equal to the change in velocity over time. Well, our change in velocity is our final velocity minus our initial velocity. So our final velocity was 15 meters per second minus our initial velocity of 25 meters per second, okay, divided by our time of 4.0 seconds. Okay, so we have 15 minus 25 is 10 meters per second divided by 4.0 meters per second, which gives us 2.5. 2.5 meters per second squared. And that should have been 4.0 seconds, excuse me, not 4.0 meters per second. So 10 meters per second divided by 4.0 seconds that it took to decelerate is, and that should be negative, excuse me, 15 minus 25 is negative 10. Negative 10 divided by 4 is negative 2.5 meters per second squared. So my acceleration is equal to negative 2.5 meters per second squared. Okay, so that means that my force, okay, the force to slow it down, is equal to the mass that we were given. So the mass is 1750 kilograms times our acceleration of negative 2.5 meters per second squared, which will give us a force, a total force, a net force, or applied force of negative 4,400 newtons when we round it to our two significant figures. So negative 4,400 newtons, so negative 4,400 newtons is required to decelerate the car from 25 meters per second to 15 meters per second in 4 seconds. Okay. Number 3, it says a crate of supplies is dropped from an airplane. The mass of the crate, including its parachute, is 148 kilograms. Okay, so mass is equal to 148 kilograms. Okay, so 148 kilograms. What is the acceleration? Okay, so we're looking for acceleration. Acceleration equals what? If the force due to air resistance, okay, so the force of air resistance is equal to 1/4 of, so 1/4 times the weight. Okay, so we need to remember here that weight is the same as the force of gravity. Okay, so force of gravity is equal to weight. So that's the first thing that we need to figure out is what is the force of gravity acting on this. Okay, so the force of gravity is equal to, okay, so the force of gravity on the crate is equal to the total mass, so 148 kilograms, times our acceleration due to gravity is 9.8 meters per second squared, okay, which gives us a total weight or a total force of gravity of negative 1,450.4 newtons. And that's going to get wound up getting rounded later. Okay, so in order to figure out the air resistance is 1/4 of that force of gravity, or 1/4 of the weight. So the force of air resistance is equal to, I forgot to assign here, negative 9.8 meters per second squared. That's how we wound up with negative 1,450.4 newtons. Okay, because that's a negative 9.8 because we're acting down. Air resistance is acting up, so it's going to be positive. 1/4 of 1,450.4 newtons, which is equal to positive 363 newtons. Okay, so that means that the net force, is the sum of those two forces. So my net force, okay, air resistance is going to cancel some of that out. So negative 1,450.4 plus 363, okay, is approximately negative 1,087 newtons. Okay, so that's my net force. So in order to figure out the acceleration, acceleration is equal to the net force of negative 1,087 newtons divided by the mass, okay, which is 148 kilograms. So that means that my total acceleration is equal to 7.35 meters per second squared down, so negative. So you can either say negative 7.35 meters per second squared, or you can say 7.35 meters per second squared in the downward direction.